Hi, good afternoon everyone. So this paper, the Djed Shu Stablecoin protocol, is an improvement over the already existing Djed protocol, which already has various versions of it. Some is the minimal version, and then the OSS version, and then there are implementations of it on other blockchain as well. What the Djed Shu protocol does is it improves on the existing Djed protocol by introducing two oracle prices instead of one. And this paper is written by Dr. Bruno and me. Let's get started. First of all, I would like to explain in very brief what is Djed. So Djed is an algorithmic stablecoin. So unlike USDC and USDT, which are backed by a fiat asset such as USD, and it requires some kind of reserve, what an algorithmic stablecoin is, it allows the price of dollar to be pegged on blockchain by using mathematics and formulas instead of an asset in the bank. And how it does is it relies on majorly two types of coins, such as the stable coin, the main stable coin, and a reserve coin, which is used to provide liquidity and reserve to the stable coin. And so let's get ahead. What Djed has are four the main basic important functions: the buy stable coin, sell stable coin, buy reserve coin, and sell reserve coin. The important thing to note here are the conservative functions, which are the buy stable coins and the sell reserve coins. I'll explain how these are the conservative functions, and this is closely tied to our Djed Shu, where we use the minimum and maximum price of oracle. So first of all, let me explain what the minimum and maximum price of an oracle is. So what we do is we'll maintain a 24-hour window where we calculate a global minimum and a global maximum, and we say that okay, this is the maximum price of the oracle over this 24-hour period, and it changes as the hour progresses. So at each point of time, we have two prices of oracle, and we choose to implement the lower or the higher price of oracle based on the user action. If they want to go with the buy stablecoin function, we use the maximum price. The reason being, we want the protocol to benefit from the oracle price that is being used, not the other way around. This may sound like counterintuitive at the first sight, but what really helps is we would never want the reserve to run out. So the slight change or the slight benefit of price is always given to the protocol rather than the user. And in most cases, these prices are not supposed to be very far from each other. So the difference between the max price and min price is hardly noticeable to the user. So there's no real loss for the user in this case. So as I said, the buy stablecoin function is a conservative function. And how is this a conservative function? Is we inflate the price of the stablecoin a little bit by using the max price, so that the user has to pay more, which in turn benefits the protocol. The same can be seen in the sell reserve coin function, where we deflate the prices of the reserve coin. So the protocol earns more when the user is selling their reserve coins in place of base coins. And the same can be applied to sell stablecoin and buy reserve coin, where we use min price instead of max price. And in these two functions also, the protocol benefits because the user earns less as compared to what they paid when they were buying or selling the stablecoin and reserve coin respectively. So I hope this is clear. And the next we'll go to one of the most important component of this Djed Shu protocol, which is the oracle converter. What it does is it is a piece of smart contract in our EVM compatible chains. But what we are trying to do here is we are trying to convert the already existing one price oracle and not create our own oracle, but rather convert that one price oracle into two prices for our Djed Shu protocol. And as I explained previously, we maintain an order of 24 hours. There is a reason why we are maintaining an order of 24 hours. First, we had this place in keeping mind of the EVM compatibility, and as we know that in EVM, arrays takes a lot of space, and traversing the arrays again and again costs quite an amount of gas, which includes writing and both write and read operations. So to minimize that, we have chosen 24 hours, 1 day as a number, but we can increase or decrease it based on further data as we observe. It also depends on the amount of transactions users are going through. So the update oracle price occurs each time user performs either a buy or a sell function. So a particular amount of gas is being utilized there, and the order of the array matters on that. And the oracle, I'll go back a step. The oracle converter has certain features. The first being the hourly price aggregation. So what it does is it keeps in mind the fact that the price of the oracle can change multiple times in a particular hour. What I mean by that is, suppose the time right now is between 11 p.m. to 12 p.m. and at 11:01 the price of an oracle, judging by today's price, 1 USDC is somewhere around 0.006 ETH, and this price can change in this hour also. So we want to maintain that average decorum of the price, and how we do that is by averaging all the prices or in that particular hour by the number of times it has updated. So for example, it has been updated 5 times. So we take all the prices of that hour and we average it by 5. This is the formula that we use to calculate the current hour so that it fits in the 24-hour window of our array. For example, the hour right now might be more than 24. What I mean might be more than 24 is the current hour based on the Unix timestamp is always greater, and we use the mod 24 calculation to make sure that it belongs to our 24-hour array. And here's a step-by-step example of what I just explained, just in a numerical sense. I think there's some error in the PPT here, so we might see undefined here. But the important thing to note here is the formula that is written up there. So what it does, it calculates the average price in that particular hour, and I think the formula is somewhere wrong, but okay, I'll walk you through it. Then let's suppose it is the first iteration of the hour, and so judging by the formula, we'll put ki equals to 0, and the price, the first hour price is already 0 since it has not been updated. And let's say the first hour price is 100, so we automatically get the price as 100 only. And in the next hour, let's say the price has been updated to 104, and we can do the basic calculation. So 104 plus 100 divided by 2, since it is the second iteration, we'll get 102, and the list goes on. So it maintains the average price of that particular hour. The next thing to note is computing min and max prices. So as I explained, it maintains an average, a global average. So at any point of time, we can see what the current min and max price is and to what hour that belongs. Now suppose there was no user action, there was no buy or sell reserve coin or stable coin. So the oracle will not automatically update any new prices. Let's say there has been no update from price 2 to 7, and there is now an update in price in hour 8. So the price of hour 2 to 7 will automatically be what the price in hour 8 is. We will not perform any additional calculations for hour 2 to 7 because the user did not perform any operations during that time frame. This is again to save gas on EVM compatible blockchains, and in general to reduce the number of read and write operations. Now, going further, I'll explain the 3 basic commodities of our Djed protocol. The first being the reserve. So, what does reserve say? Reserve basically says the total amount of balance we have. The reserve basically says the total amount of balance we have in our blockchain. So the total amount of money that our protocol currently holds. This is the contract balance, and what minus pay suggests is that, now this is very important to note here, because if we don't put the minus pay calculation here, the buyer of either the reserve coin or the base or the stable coin can inflate the prices of the reserve and stable coin. How it can do is, it can, because what the pay here is, the pay here is basically the amount the user is sending to buy the said reserve or stable coin. So they can inflate the prices of, they can change the prices of R in turn changing the price of with which they buy the stable coin or reserve coins. So reserve is basically the total amount that the protocol holds, but we don't include the amount that the user is paying for the current transaction. What is liabilities? Liabilities amount to the total sum of money required to buy back all the stablecoin that is currently in supply. So let's say currently there are 100 stablecoins in supply, and the current price of the stablecoin is $1.01. So the liabilities will be equal to 1.01 into 100, which would amount to all the money that is required to buy back all the stablecoin. It is very important for the protocol to maintain a threshold of reserve and liability. So in case anything goes wrong, the protocol has the money required to buy back all the stable coins, and any user who has purchased a stable coin does not go into fault or does not get bankrupt. The next part is the equity. Equity is basically the leftover money from reserves and liabilities. What it does is it powers our reserve coin. So the prices of reserve coin is based on equity. If equity amounts to 0, it means that our protocol does not have any extra money left, and thus the reserve coin has no additional value at the moment. But if the price of equity is more, which means our reserve has more money than the liabilities, which means in further that the protocol has more money, then it is required to buy back all the stable coins, and in this case only the reserve coin has the power and the reserve coin has a price associated with it. And if the price of equity, if the equity amounts to less than 0, then it simply means that our protocol has been broken, and this condition never actually comes true, because we have certain conditions in check when anyone is trying to buy or sell a stable coin. So now I'll explain the stablecoin price and how we are calculating it. So before I go into the stablecoin price, I would like to explain two more terms here. One is the target price. Target price is the worst price that we consider, and it is generally used when there has been no stablecoin already in the market. So when the protocol is deployed freshly, there is no stablecoins, and we use the target price. The value of target price is the oracle price currently. So and again, this depends on the min and max oracle price, because in Djed Shu we have two prices. So if someone is buying the stablecoins, we use again the max price here. So initially the target price is the max oracle price, and the max oracle price is nothing but the value of $1 in base coin. So if we have deployed it to an Ethereum compatible EVM chain, then base coin is Ethereum, and we'll have the price of $1 as the target price. So we take the minimum of target price and backing capacity. What is backing capacity? Again, it is very intuitive. Backing capacity is nothing but the total reserve divided by the amount of stable coin already in supply. So let's say somebody has bought 2 pieces of stable coin for $200, then the backing capacity already becomes $1 for a stable coin. And we take the minimum of the target price and the backing capacity for each time we want to describe the price of a stable coin. Let's go over it by an example first, so that it's easier to understand. Let's say we have 1000 base coins in reserve. By base coin here I'm assuming Ethereum, and the stable coin supply is 1200, and the oracle target price is 1 base coin, which is $1. So backing capacity becomes 1000 divided by 1200, which is 0.83. Now it is important to note that we'll take the minimum of the oracle target price and the backing capacity, which comes out to be 0.83. Why we are taking minimum here is important, because backing capacity states that we have this much power to buy back all the stable coins, which we saw in our liability section. So it is important that protocol does not overstate what it can do. If the protocol states that it has the backing capacity of 0.83, then we'll have to assume that at this point of time protocol can buy only this much stable coin back, and if we issue new stable coins at the price of oracle target price, then we might be leading to protocol insolvency in the future. The next section is reserve coin price. Now if we remember, reserve coin price is determined directly by the equity. equity is nothing but the extra money left in the protocol. So we'll see further in the example and the formula how the reserve coin price is defined, but it is very important to note that reserve coin price is only defined by equity, just how stablecoin price was determined by the reserve we have left. Now, we'll go through the formula very carefully here. Now, let's say we currently don't have any reserve coin in our market. So what Djed Shu does is it defines certain parameters. The first being the initial reserve coin price. So we already state that the initial reserve coin price will be this while deploying our protocol. So that for the first reserve coin that anyone is going to buy, he has a price associated with it, because in the beginning there will be no equity, and if we don't start issuing the reserve coin in the beginning, then we'll never acquire the reserve we need to further the protocol. But if we have reserve coins in place, then the price of reserve coin becomes the maximum of the, we also have another parameter which is the price of a minimum reserve coin. So we don't want the reserve coin price to go below a certain threshold, and so we have these two parameters. We also have reserve coin maximum, so we don't want the price of reserve coin to go above a maximum threshold also. But if you already have reserve coins in the system, then the price of a reserve coin becomes the maximum of equity, which is the leftover money, divided by the total number of reserve coins in circulation, and the minimum reserve coin price that we have. So we'll take the maximum of these two. Again, the oracle price which we choose depends on the buy or sell functionality of the reserve coin. If we are buying a reserve coin, then the oracle price which we'll use is the minimum oracle price. But if we are going to buy a reserve coin, then we'll use the minimum oracle price. Next is the reserve ratio safety. So this was an important parameter that we had set in Djed and Djed Shu both. I'll discuss further in the future implementation section what we are trying to do here. But currently the reserve ratio safety states that if the reserve ratio falls below a minimum threshold, then we don't want to allow buy and sell operations. And the same goes for the maximum threshold. If the reserve ratio max is set as certain threshold, and if the current reserve ratio goes above that, then we don't want to allow max and min operations. Why this is done again is to maintain a certain solvency in the protocol, so that users are not able to inflate the prices of reserve coin and over collateralize the protocol, and at the same time users are protocol doesn't become insolvent and it goes below a minimum threshold here. And next we go about the advantages of Djed Shu. The first one is the dynamic spread protection. What it does is during times of high volatility, when the price of an oracle is not final. What do I mean by not final is there are lots of changes in the price of an oracle. There are certain oracles which are not very stable at the moment, and which are backed by certain individuals which have a centralization risk. So we can see that in a particular hour the price of oracle fluctuates, and in that sense this plays a very important role because this averages the fluctuation in prices. The next is resistant to oracle attacks. This also includes the sandwich attacks and the arbitrary value that users sometimes tries to hold. And this provides a certain type of protection against oracle attacks, because we don't use a single price and we use the average of all the prices, and we use the min and max price according to the operation that the user is trying to perform. Next is the gas efficient design of our oracle converter. So what we'll note here is that we have been we have kept in mind the gas required very much here, because in each operation, the read and write operation, in each buy or sell operation, we go over the complete array of 24 hours and we perform read and write operations there. So it is very important to note that users don't pay much in gas than what they're trying to pay for the stable coin or reserve coin. And what we're trying to do with Djed in the future. So the current implementation includes the Osiris and the Shu. Osiris is the Djed contract that we already have deployed on certain blockchains, and Shu is the improvement over the existing Osiris implementation, which we have discussed here. For our Osiris implementation, we have ETH as a reserve coin, and for Shu also we already have ETH as a reserve coin. But what we are trying to expand here is, or what direction we are trying to go here is, we don't want a particular reserve coin, we don't want a particular base coin to be fixed. We want users to be allowed to deploy Djed with their own base coin in mind. The problem with this approach often comes with the fact that most of the ERC20 tokens are not trustable. They have certain loopholes. So any type of ERC20 token they deploy cannot be trusted. But this is the type of approach we want to take in the future, where we can allow users to deploy their own version of Djed with their own base coin, which would certainly lead to more stability and more decentralization. We already have the front end available for the Osiris and Shu versions, and there are certain more projects that are coming up, which will be explained further in our workshop today. One of them being the Oracle, and we also have a stable pay widget available, which allows people to pay through Djed stablecoin. And regarding the future evolutions of Djed, there's already a Djed testnet in place which we are working on. What it does is it eliminates the risk, it eliminates the reserve ratio. Now it has a certain risk associated with it, as then users will be able to buy and sell stable coins and reserve coins at any price point. But as we have come across in the past, that having this check allows, in case a blockchain or a side chain is not supported by the ecosystem anymore, it is very hard for users to redeem their funds. And we had this check in place, and we are considering to remove it in the future, so that in case something goes wrong, users' funds are not locked. And the next evolution I've already talked about, that we want users to deploy their own coin and deploy their own version of Djed in the future using their own base coin. And with that, I would like to end this presentation. Thank you. If I have any questions.
So, how you have validated your work? Yes, sir. What is the process to validate your work? Have you just applied any? Have you done any use cases for that?
So we already have have an implementation of this. So Djed Shu is not yet deployed on the mainnet. It is already deployed on testnet. We have deployed it on Ethereum Classic testnet. The users are yet to come, but we have done our internal round of testing where we have implemented buying stable coins and reserve coins both, and the math has proven right up until now. But we would like to apply it to a larger user base to see how the protocol behaves and how the protocol works in future. But we already have a very good working implementation of Djed Osiris, which the Djed Shu inherits from.
Did you find similar type of framework existing already? Just like that, have you done literature survey regarding this?
The min and max price approach hasn't really been explored yet, because a lot of ecosystems already have a trusted Oracle provider in place, and they assume that the Oracle provider never fails, which is not true. A lot of times these Oracle providers are also decentralized, and they also have a backing asset in place. But we are considering the possibility that in case the Oracle provider malfunctions, or in case the Oracle provider doesn't behave the way we expect them to, what are the safety precautions we have in place?
There is a trilemma in a stable coin.
Sorry?
So there is a trilemma in a stable coin, so cannot achieve all the three. So in this, what has been sacrificed out of?
So what I would say is scalability might be sacrificed a little bit, because the amount of operations we are doing in a certain buy or sell operations is quite a lot, and users will have to pay more for the. So let's say the Oracle does not behave inappropriately, or let's say the Oracle does behave the way we want to. We are paying an additional amount of fees for no reason there. One other thing I forgot to mention is that right now we are charging 2% flat fees, but because of the flexibility we have with the min and max prices, which allows the stablecoin to earn more, we can gradually reduce the flat fees that we have currently. So this in turn benefits the user. But I say scalability is the one thing that we might be
There
satisfied.
are three things: decentralization, stability of price, and collateral. These three you cannot achieve together in stable coin. So out of these three, which you are focusing and which you are sacrificing?
Can you repeat again which three you're talking about?
decentralization, complete decentralization, stability of prices, and what is collateral.
We don't have a collateral here. So
So this is insured,
this is
and capital efficiency is there.
yes.
What about decentralization and stability of prices? These two. Out of
Stability
these two,
of-
some you must be, because it has linked to some mathematical problems which are still unsolvable. So what you are,
I would say stability of prices because
it is implemented or sacrificed?
I can comment a little bit about this. So yeah, when people talk about the stablecoin trilemma, and that, for example, it's capital inefficient, they are usually referring to crypto collateralized
Yes.
stablecoins like DAI, for example. And Djed is a crypto-backed stablecoin. It's a bit different from crypto collateralized stablecoins. It still has a bit of a capital inefficiency problem. So in the of the three corners of the triangle, it's still the case that capital efficiency is the one that is sacrificed, but it's less sacrificed. Why? Because in a crypto collateralized stablecoin like DAI, that surplus collateral is just idle there in the contract. But in a crypto-backed stablecoin like Djed, the surplus reserve, not collateral, the surplus reserve is tokenized. And these reserve coins, they are tokenizations of the reserve surplus. So they're not completely idle. You know, you have a token that represents a share of that surplus, and that token can be freely traded and freely used in other DeFi protocols.
So it can be traded for other purposes or other.
Yeah,
Some revenue can be generated out of it.
yeah.
Yeah, you can put it in the LP and
Yes. So this is what you. But that's fine.
And then, yeah, it's fully decentralized, so fully autonomous on the blockchain, right? It just depends on an external oracle, so there may be some centralization in the operation of the oracle. Yeah.
And the price stability.
Yeah, price stability depends on the oracle. Yeah. So yeah, with Djed Shu, compared to previous versions of Djed, we so with previous versions of Djed, we protect against oscillations in the oracle, delays in the oracle, manipulations of the oracle with a fixed fee. With Djed Shu, we have a more dynamic way of adjusting this fee, you know, to protect against oracle delays and oracle manipulations.
So I think this problem is linked with some mathematical chaotic theory, and then it is somewhat some unsolved mathematical problem which cannot. So I have read somewhere. Is it like that? I'm not actively doing research in this area, but is it like that? It has something to do with some mathematical unsolved problem over there.
Yeah, when people talk about the stablecoin trilemma, it's more informal, right? I have never seen people actually formalizing the trilemma as an impossibility theorem,
Okay,
for
so it is
example.
kind
But
of
it might be possible to do
conjecture
that.
kind of thing.
Yeah.
I think it should be possible. Then the question would be about model where you have proof right against.
So no mathematical progress is happening in this side, or just it's kind of conjecture. Nothing is moving ahead.
Not yet, but about all those trilemmas, so usually, you need to generate some model, right? And then proof is generated against this model. So this is how it's done for CAP, for example.
Can you spell out again what?
CAP, consistency, availability,
Okay,
partition tolerance.
so
right?
that is that
So it's from distributed
distributed
systems.
cap.
Yeah. And how is it proven? So there is some model, right? And there is some proof against this model, but then the model itself is challenged. There is a lot of debates in distributed systems about this. Does this CAP make sense or not? So here it would be the same. So you need to consider some stablecoin model, right, and then prove this trilemma. But then, the question would be: is this stablecoin model covering all the
stable coins.
So basically, this in the area in which I work, that is decentralized exchange, there is a problem of impermanent loss,
Right.
and people are not now formalizing it with mathematical models. So now for impermanent loss, it is moving to LVR, and LVR they are trying to model with the probabilistic process, and they are coming up with limitations whether it can be solved altogether, or if it is not, then how to compensate it with fees. So you need exact mathematical functions and model which can tell you this is the loss which is going to happen if you follow this kind of curve, and then you can compensate with fees or some other ways. So a lot of formalization is happening in decentralized exchange. And there is a course in Princeton from Vishwanath, some professor is there, and he is at course on DeFi, and he has devoted a lot of classes on that part, formalization of decentralized exchange and all. So a lot of papers are coming. Millennials is their famous pioneer in this field, and he's writing on that. So formalization. So I was asking, is something of that sort is happening in this side or not? Formalization, mathematical.
Yeah, so in fact, Djed is, to the best of our knowledge, the first stablecoin protocol that has been formally verified. Djed Shu, this version in particular, we haven't proven theorems about it. We haven't formalized the proofs, but the previous version, the minimal Djed version, we have proven 8 stability theorems. And all these proofs have been formally verified in a proof assistant, in an interactive theorem proof.
Implementation or certain properties?
Properties of the protocol itself.
For certain properties, this is what you put as specification, and this is achieving that. That's what.
Yes. Yeah.
So yes. So I had slightly different questions. So all three: what can be done, what cannot be done, then limitation of that. That kind of work I was looking for. If there is something of that sort.
So some impossibility results.
Yes, sir, that's right.
That would be interesting
Yeah.
to consider.
So if that kind of some people may be pursuing that will be quite good to know the limitations, theoretical results. So this is happening in DAX. The loss is permanent loss is the major flaw. If you can overcome, then a lot of things will improve.
And there are people trying to show some impossibility results that you cannot really eliminate it completely.
After the limitation, then you can model how you can overcome that mathematically, and then you can compensate it with that.
Yeah.
But here I don't have idea because I'm not doing much, but I know some trilemma is there, and whether people are doing it mathematically, I'm not aware of it.
Yeah, I think mathematically not yet. Yeah, only informally. Yeah.
What do you mean by impermanent loss?
Not here.
There
is a loss. So altogether different.
Impermanent loss of the like assets or?
No, there is a loss in DAX because due to the inherent nature of curve. So traditionally, market makers used to be there. No? So now that has been removed and it has been decentralized through equations, and that inherently gives some loss. So earlier it was impermanent loss. Now they have pinpointed it to LVR. They moved from impermanent loss to LVR, and now focus is from last March. This to March 2025, people have pinpointed the issue that is LVR, and now they are modeling it mathematically, how it can be reduced, and if it cannot be reduced, then how it can be compensated. So to compensate, you need mathematical thing, how it is behaving, and then it can be tackled accordingly. So this is where a lot of work is going on, and a lot of people are doing stuff.
Great point, actually.
So, good topic for next workshop then. Impossibility results. Coins.
Yes, last 8 months, a lot of things have moved on in that side.
Yeah, and so with impossibility results, then we can say that certain designs are nearly optimal, right? Optimal. So if impossibility results are known, basically limits are known, then yeah, you can argue that some designs are close to optimality.
So
optimal.
Yeah, so the more you know about the problem, the things will be more control for you. So if you don't know about the problem much, then it will be out of control. So you mathematically model for that purpose only, to get control of, know the limitation and everything. Then you can tackle the problem accordingly. So that is what is happening exactly.